Higher Notes 1.0, Vectors, Scalars and Acceleration. In this note, which is part 2 of this section, we're going to look at vector and scalar definitions and velocity and speed and how they differ. So we're actually going to look at learning outcome number 3 first, which is the definitions. Well, a vector quantity has both magnitude and direction. Whereas a scalar quantity has magnitude only. That's size, no direction. And learning outcome number 2 gives two very well-known examples of each of these types of quantity. So for example, speed is a scalar quantity. It has no direction. And if you were to use an equation to work out a speed, you would use the familiar equation to your speed is distance over time, and in symbols v is d over t. D, the distance, is measured in meters, that's the SI unit. Time t is measured in seconds, and the speed v is therefore measured in meters per second. It's a scalar quantity, of course, so no direction is required. Compare speed with velocity. Velocity, of course, is a vector quantity. And when you define velocity as an equation, it becomes v is s over t. So notice speed is distance d over time, but velocity is displacement over time. So s, the displacement, is measured in meters, and that of course would have a direction, and the direction of that displacement would also be the direction of the velocity vector. Time t is measured in seconds, and velocity therefore is measured in meters per second. Now I should say it is possible to have displacements and distances in kilometers and times in hours, so you should be able to work with those non-SI units if required. Okay, so that is the difference between velocity and speed, and between a vector and a scalar quantity.